All right. So I think we have all seen, even just in the last few years, how quickly AI has advanced, right? And that has sparked so much innovation. It is transforming economies and even daily life. But like any emerging technology, right, the implications of AI are still a little murky. They're still a little uncertain. Now, in this next session, we have three incredible panelists who are going to help us look at the promising opportunities AI presents and the challenges, right, specifically around the significant energy requirements that AI poses as we grapple with this ongoing energy transition. So I am very pleased to welcome Kamini Aisola, the Director of EMEA Specialists at Amazon Web Services. Her team provides expertise to businesses and organizations across industries. This covers everything from storage, databases, security, analytics, Gen AI, machine learning, and robotics. We have Khareghani, who is a professor of practice in AI at King's College London and AI policy lead for Responsible AI UK, a £35 million grant connecting responsible AI research and innovation. And lastly, Guido, who is Director of Engineering at DeepL, the neural machine translation service that's one of Europe's most exciting startups. So come on up, and we will get going. All right, welcome, welcome. So let's jump right into it. Kamini, let's start with you, and let's talk a little bit about Amazon Web Services. So the adoption of AI tools, right, we know this, it is growing exponentially at really, really, really rapid clips. Now, companies like AWS are building data centers around the world to meet this surge in demand. So what impact do you foresee from the growing demand for cloud services, like what you provide, on the overall energy infrastructure?
Yeah, thank you so much, and it's really a pleasure to be here. So first of all, I firmly believe that AI is one of the most transformative technologies of our generation. So there's a lot of opportunity ahead of it, not just in terms of what everyone might recognize from a consumer-focused standpoint, but also to address some of humanity's greatest challenges, including the climate crisis. So as a starting point, if we look at the size of the prize, right? What is the size of the prize? I think we have some data around this. We had a report earlier this year in February 2024 with Strand Partners for AWS that estimated that just in Europe alone, AI has the opportunity to add 600 billion euros of value across EMEA.
Wow.
Across Europe. So, but one of the things that we should remember is that the true potential beyond this lies in the opportunity of AI to address critical social challenges. Now, AI for Amazon isn't something new. We've been doing artificial intelligence and machine learning for over 25 years. We've also been working very extensively on optimizing how we run data centers, ensuring that we continue to innovate on all aspects of it, everything from the energy aspect, water, all the choices that one would make. But I think what I wanted to maybe emphasize here is the climate pledge, something that we've been the founders of and the first signatory in 2019, which is a commitment that we have made to become net zero carbon by 2040.
Okay.
And as a matter of fact, 7 years ahead of our 2030 goals to be 100% powered by renewables, we actually hit that goal in 2023.
Wow.
So these are some of the aspects of it.
And when you think about exploring sort of, looking to improve energy efficiency at both the data center level and then sort of within the larger energy ecosystem, what technologies is AWS exploring? Sort of, are there examples of innovation that you're excited about or particularly bullish on?
Yeah, so I think one of the, we use a framework looking at sustainability off the cloud and sustainability in the cloud.
Okay.
Sustainability off the cloud is how we make AWS's infrastructure as energy efficient as possible. And sustainability in the cloud is how you provision and architect workloads to be as energy efficient as possible. So when we talk about sustainability off the cloud, we look at, for example, research estimates that AWS's data centers are up to 4.1 times more efficient, energy efficient, than running those same workloads on premises. And this comes from kind of a long history of continuing to look at improving power efficiency in every aspect of our operations. One of the things that I wanted to call out today was some of the innovations that we're doing on the chips, right? AWS Graviton chips. Our processors deliver highly performant returns with high levels of energy efficiency. And in fact, the most recent Graviton 4 processors that we released are a supreme and extremely higher, let's say, have delivered considerably higher performance based on even our previous iterations of the same chips. So as an example, they provide up to 30% better computing performance, 50% more cores, and 75% more memory bandwidth just compared to the Graviton 3 chips. Now, this helps customers with using the technology and the innovations that we are providing as sustainability of the cloud in the way they would deploy their workloads, and as a result, kind of contributing to that full spectrum. One more thing that I wanted to just say was around the design of our data centers. A lot of the work that we've done around using natural airflow as an example that helps us to reduce air conditioning efforts. And then I mentioned water earlier as well. We have a commitment to be water positive by 2030. And this basically means that we are returning more water to the communities than our use in our own operations. So we are currently 41% of the way to reaching our water positive target.
And you talked a little bit at the top about how long Amazon has been working in the AI space. You also talked about how AI has the potential to really contribute to solving the climate crisis. Is there anything in Amazon's approach to AI specifically that is sort of helping to advance or innovate on sustainability goals?
Yeah. So I wanted to maybe use a couple of examples here. Now, AI has an immense potential to help address critical environmental challenges, and one vital application is in the management and optimization of electricity grids. So we, as a business, are very, very much in support of the EU's grid policy, right? Some of I think it's been discussed earlier today as well. So one specific example here is we are empowering companies in the energy sector to leverage AI and machine learning to optimize renewable energy operations and reduce consumptions. If you take a look at the advent of much smaller and distributed sources like rooftop solar panels, AI can play a critical and I would say even pivotal role in many cases in accurately forecasting supply and demand and making sure that this complex data in real time is available in order for all kinds of institutions to offer strategies to optimize the flow of electricity. Now, beyond grid management, another important and let's say untapped source of how we would put AI to work is in generating sophisticated forecasts to aid in climate resilience and adaptation. As an example, we've been working with a Brazilian nonprofit organization called Celo Verde to create large-scale AI models for monitoring deforestation. The model that this organization has developed covers 20 million hectares of the Amazon rainforest, and it enables the restoration of an estimated 3.4 million hectares of forest within the state of Pará in Brazil. So these are a couple of examples, and the use cases actually, they extend beyond this, right? Another important use case is tracking the progress and of efforts such as reducing the impact of packaging. And this is one of the things that we can share just from our own organization. Amazon has developed something called a packaging decision engine, which is an AI-powered model to analyze product attributes and define the most optimal packaging, which has a vast implication across all aspects that one can imagine, not just from a pure material usage and supply chain, but many different sustainability aspects associated with packaging.
Fascinating, thank you. It's really interesting to me, and I think we'll touch on this in a little bit too, just sort of how much potential AI has in helping with this climate crisis that we're in, that we're sort of confronting, and helping, contributing to this energy transformation, while at the same time, the technology itself has really significant implications. And with regards to sort of its own climate impact, it's an interesting tension. Guido, let's turn to you. So DeepL is an AI-driven startup, and you've seen really rapid growth, a lot of success. So how do you balance the need as a startup, especially sort of in the AI space, right, which is very crowded, very competitive? How do you balance that need to innovate, right, and to move quickly with the goal of reducing your carbon footprint and sort of being, thoughtful when it comes to the implications of the energy requirements of AI?
Yeah, thank you. As DeepL is primarily traditionally a researching company, we have a really hard time to actually balance between our innovation that serves new translation models or higher quality for all the hundreds and millions of users we have out there. So it's really hard to balance between actually our fuel that we have for all our users. So we do have, instead of that, have looked into very thoughtful sustainability procedures together with our partners. So we have very innovative partners in our data centers that support us with our carbon footprint at first, but not at all. So the other aspects of sustainability, like water or groundwater usage and things like that, or even the other scope areas, like what type of materials are used in the buildings, and how is the actual architecture of the data center built in regards to sustainability. So that's our approach to cope with the non-negotiable high demand of electricity need that we do need to train our models at a quality level that we would like to achieve and to provide for our users. So, and I'm also super happy to dive a bit deeper into the stuff that we are doing in detail, actually.
I would love some specific examples. Yeah, I'm very curious about this, please.
Yeah. So we've actually been quite lucky since DeepL did this massive scale over the last year. So as a rather young company founded in 2017, we would have actually been challenged a lot by all this scale and growth we've seen over the last 7 years now. But we are pretty lucky that in the early days, actually our founders already had this sustainability of our data centers in mind. So we had already started in rather Nordic areas where we do have this rather cool open air flow, which just reduces the energy demand for cooling, reduces the overall power consumption. This is just a basic first thing you can do. Also, we are super lucky to have to make use of a lot of renewable energies, mostly of geothermal, wind, and water power that is available in Nordic countries. Especially, we have our data centers in Sweden and Iceland, and especially with our partner in Sweden, we also going the next steps here, like having from the ground up built data centers that serve the demand for sustainability. So they do not have mostly no concrete, usually using wood as a base material for the data center. Yes, it might burn, but it burns much slower than you would expect, and it's pretty much serving the expectation that you would need to have in this case. It has, of course, like solar power where they can, but this is just a tiny fraction of the power that we use. They are working also heavily on changing their cooling water supply from groundwater usage to like upper water from open water sources, which is really contributional also to the local area. And very interesting aspect is like also integrating the data center in the heat, the left heat of the data center with the local neighborhood around the data center. So we do have, in this particular case, there is a plant that is creating wood pellets out there, and they're reusing our heat to dry these wood pellets, which can overall then afterwards be used for heating, like around in the buildings. and the remaining heat is used for district warming around in town. So there is a huge effect around this area then.
And when you look ahead, what do you think will be the most critical advancements in the years to come that will allow startups like yours, right, and others working in the AI space to continue to reduce their carbon footprint? Is there anything that stands out to you in terms of innovation or policy that you would love to see or that you think is really necessary to continue making progress here?
Really hard to say from my perspective. Of course, so I'm an engineer. I'm looking from the technological side of things. And of course, we're all waiting for the next big thing in hardware, how to make it faster. Like we're currently using AI accelerator cards, which are technologically based on GPUs that were actually built for playing games like 15 years ago or so.
Yeah.
And there's a lot of potential in having more targeted, specialized hardware for two kinds of workloads. The one workload is training the AI, but the other one is also inferencing. And I do personally see a lot of potential in inferencing because the model that pops out of a huge training, especially for LLMs, is usually not very optimized in terms of efficiency. So to me, that's the first half of the job, and the second half is then making this run much more efficient than the original source that you have.
Right, got it. Now, Sanna, let me turn to you. I would say, and I think you would probably agree, the past few years have proven, yet again, that it's very hard for lawmakers to keep up with the pace of technological progress. So when you think about AI regulation, and you think about making sure that we are able to innovate and move quickly, but also move sustainably, what are the biggest challenges that you see in sort of the regulatory environment to strike that balance and sort of make that happen? Not an easy question.
No. Thank you for starting me off that
No
way.
problem.
What an amazing venue, by the way. Really amazing. And thank you for having me here. So I think the two things I would say that make this incredibly difficult is, one, the pace of change, and two, the fact that AI touches kind of everything that we do, both at work and in our everyday lives, which means that regulators are looking to generalize in terms of regulation. So how do we, in general, regulate AI? And that makes a very tough ask because AI isn't one thing. Even though we call it artificial intelligence, which makes it feel like it's one thing, it is a term that encompasses a whole host of different things. So it's everything from auto-completing your emails or your text messages to facial recognition, opening your phone or getting you into your bank account. It's following the little blue dot on your phone that gets you from point A to point B with the least amount of traffic. Or it's the scientific advancements that we've seen with regards to DeepMind's AlphaFold, which, for example, Sir Demis Hassabis won a Nobel Prize yesterday, right? So all of those things are considered AI, and this poses a problem for regulators because it's all happening at the same time.
Right.
And so right now, we've got two big approaches that have been put forward. One is by the EU AI Act, which is a horizontal regulation, which is risk-based, that says, we'll see how risky the application is, and then we will, I'm simplifying a huge amount, by the way, and then we will regulate based on that. Or there's the approach that's posed for now by the UK government, which is sectoral-based or vertical regulation, which says we'll go to sectors, we'll go to sector regulators, and based on their expertise and the context under which the AI is used, we'll decide to regulate and figure out how the principles manifest. Probably neither of them are right, and probably the answer is somewhere in the middle. But where we stand right now is that regulation is coming. Whether it's going to be right, well-timed, aligned across the world, that all remains to be seen. What we do know that it's going to be complex and complicated, and it's going to need dedicated teams at corporations to be looking at it all the time. We also know standards are coming, and that I think is the thing that most people are really excited about because that gives you that ability to interoperate internationally. Because that international aspect of AI regulation especially is hugely important.
And when you think, sort of a similar question to what I asked Guido a minute ago, when you think about sort of emerging technology or emerging strategies, does anything stand out to you when you're thinking about reducing AI's carbon footprint and sort of reducing that environmental toll? Is there anything on the horizon that you would highlight to everyone here?
I mean, it's such a good question. I think there are so many different bits and bobs here, and I think Kamini was talking about how AI itself is going to help on this as well. So, for example, DeepMind has done some work around prioritizing network traffic, which has reduced their carbon, the energy intake at their data centers by 40%. So that's just one example of AI helping AI, right? But there are other new technologies. So, for example, fusion and being able to create better batteries so that it allows us to store the power that we get from renewables so we can use them on the grid when we need them, because that's the biggest problem we have right now. These kinds of things, I think, will have a step change. Right? We today live in a world where we're nowhere on the adoption curve of AI. We really are nowhere on this adoption curve, right? So McKinsey just did a survey. 3/4 of American companies have used ChatGPT at least once. So for a technology that's not even 2 years old, this is amazing. But it doesn't mean anything, because until we figure out what the kind of killer apps are to build on top of this general purpose kind of large language model technology, we're not going to be on that adoption curve. But even if you sit today, there's been some new research that's came out around water consumption. If you take 100-word email written, that takes about 500 milliliters of water to run that work in a data center. So if you get a chatbot like ChatGPT to write a 100-word email for you, it's half a liter of water. If you take 10% of the US's workforce, that's 16 million people, and you say they do that once a week, that's 435 billion liters of water, right?
Yeah.
So that isn't the world's population. That's 10% of the US's working population.
Once a week.
Once a week. Right. So you have to. So this is absolutely an important and imperative thing for us to be looking at, pouring money into researching and investing, because this is important for all of us to get right. Otherwise, we can't reap the benefits that AI promises, either economically or kind of socially or medically.
And just thinking about reaping the benefits and sort of who stands to gain from AI, I know that you do a lot of work internationally, and I'm curious how you think we can create more interconnectedness globally around progress in sustainable AI, right? To ensure that progress maybe made in one region, right, benefits another. I think there are a lot of questions around sort of equity in terms of access to AI in different parts of the world. And I guess specifically thinking about sort of progress on the sustainability front, is there anything specific there that stands out to you?
So what I can say is I guess two big things. One is there's a huge amount of work, and no one country is going to be able to do this on their own. And two, I think countries and country leaders recognize both how much work there is and how much help collaboration does in progressing this. And the second thing is that this has started, right? So there are lots of international organizations that are pushing the frontier of this work. So we have the OECD, the Global Partnership in AI, the UN, and we've had already an AI safety summit that was attended by the world global leaders. So the US and China attended this in the UK. There's been another one in Korea, and there's a third one that will happen in Paris later this year. So these things have happened. And very recently, the UN Secretary General's AI advisory group, which had 57 experts from across the world, sat on it. They represented all sides. So they represented civil society, government, as well as corporations. They came out with a report called Governing AI for Humanity. And in it, they discuss how do we democratize these technologies? How do we start thinking about how these technologies are affecting human rights and sustainability across the world? So I recommend, I mean, it doesn't include everything, but that's not, or never is the point of these things, but it is a start of a conversation. And frankly, if it doesn't elicit people saying, wait, this is missing X, Y, and Z, then I feel like they weren't punchy enough with some of their recommendations. But it's good, and it's a start.
It's a start. Just to open it up to the group for our final few minutes here, if there is one or two things that really stand out to you when you think about how to push AI innovation forward while making sure, sort of in an EU context in particular, right? It's a lot of what we're talking about today, that this transition to renewable energy, the commitments that the EU has made in that space, what is like the one thing that needs to happen from your point of view to ensure that we can strike that balance, right? That we can cultivate and facilitate innovation, make smart investments in AI, while still ensuring that the EU is on track to meet those really important goals that it has set. Anyone?
I can start. So I think this is, I didn't talk about this earlier, but one of the challenges that we have established is around permitting, so access to the grid and permits to get access to the grid. And one of the things that has been established right now that it can take up to 8 years to get the green light to access the grid. And this permitting process is highly, highly manual. It's prone to errors. It involves loads of different decision makers, and there's quite an administrative process which needs to work and needs to function well for the process to actually be consistent. But at the same time, we can't afford this 8 years of lag.
Right.
So that's one example of where technology can actually help. We have been working closely with some organizations. Easy Permits is an application that we have. Worked with Accenture and an organization called Wind Europe, specifically for onshore wind farms, to make sure that this is a focus in EU member states, to make sure that there is an opportunity for us to shorten those timeframes, digitalize that whole process, and use technology for the broader purpose of basically addressing something that will otherwise put all of the good intentions to the side, and we don't, in fact, invest in the mechanisms that are required to actually bring those good intentions into action. So this is just one thing that I wanted to add.
Yeah, thinking of the only one thing is hard. I do also see a lot of different possibilities, but thinking of regulations and the power grid, actually the national power grid in Germany, and waiting times for the transition to green energy, while energy is like one of the most important drivers in the AI space. Yes, regulation might be necessary in particular areas, but also impactful, slim processes around that to get stuff done actually effectively.
Yeah, I mean, I would add, we have right now the big tech companies, the big hyperscalers. They're doing some stuff already, but there's no consistency across them. And then the long tail of others may be doing nothing at all. And so what we need is some consistency around what is expected in terms of what they should all be doing, because actually that will allow us to reduce kind of energy consumption across the board, rather than having some do some and some do none at all.
Yeah, really interesting. Thank you all so much. A lot to think about. All right, round of applause. Wonderful. Thank you.
Thank you.